So let us first understand what business rule optimization is. It helps to diagnose performance issues with business rules and pinpoint and address any issues using planning activity report. Activity report identify which business rules are taking the longest time to execute. Open the rules in Calculation Manager, review the log and optimize the steps within the rule to improve the performance. So we can say that we can identify the slow running business rules in planning application activity report and Calculation Manager log message. So we will see how we can view the slow processing business rules. So for that, I will go to application, then overview. In overview, below the application, we have overview, cubes, dimensions, and activity reports. So I will click on activity reports here. I will view it, and here I will get the summary where we will find the slow processing business rule. So here we have top 10 longest performing calculation script executions. So here we find that the calculation script is named as aggregate actuals, which is in plan 1 cube, and the duration is also mentioned that it took 21 seconds to process the rule. Okay, so I will close this and then I will go to the navigator. From there, I will go to rules in create and manage. Here, I will expand the EPBCS and then in plan 1, I will click on rule. Here, the rule was named as aggregate actuals. So this is the rule which was taking longer period to execute. So I will validate the rule and then deploy it. Lastly, I will launch the rule. After launching it, we find here log message. I will click on it. There I will select pass only. So here we have the log message in which we can see that we have message number. Message number is the message ID of the log entry. Okay, like for example, in a classroom, we have uh, many students and all are having their roll number. Similarly, in this case, we have message ID. Then comes the message level. This shows the level of the messages. As we can see here, info is the message level here. Then comes the message text. This actually this shows the complete text of the log entry. Okay, so we can see that calculating, then we have version, consolidated with fixed members, that is period, Jan, year, FY22. So this is the rule, okay, which we can see above here, that Our scenario is actual. Then here the period is the current month, and it is a substitute variable whose value is January. Then we have ampersand current year whose value is FY22. Then comes the currency as USD. So this is what message text shows us. Then comes the message timestamp. This shows us the date and the time. Okay, so here we have the date as 2023 February, and the date here is 3. So the rule is run on this date and the timing is also mentioned. So here then we have pass hashtag. This shows the number of current pass. The highest number in this column is the total number of passes in business rule. So here we have highest number as 4. Okay. Then we have pass time in bracket second. So pass time, this shows the execution time of the current pass only. So we can say that this particular line took 0.01 second to run the rule. Then in the cumulative time, this cumulates the time that is given in pass time seconds. The last entry in this column is the total business rule execution time. So here we can see that the total time to execute this business rule is 1.717. That is 1 minute, that is 1.717 seconds. Then comes the pass percent. Pass time as a percentage of the total business rule elapsed time. Lastly, we have cumulative percentage. Percentage of the total time of all passes in the business rule to that line. When all the passes are completed, it shows 100%. So here we can see, and at the last, that we have 100% as cumulative percent. So this is the log file, and this is how we see the log file. Now we will write a rule. So here I am going to write a rule in OEP underscore FSQ. I will right click on rule and then on new. Here I am to write name it as product revenue calculation. Now I will click on OK. I'm going to write the rule in edit script mode. So to write a rule, we will first use the fix statement. So fix statement are used to focus BR to ensure that one calculate the required blocks. So here we are going to fix the USD. So first of all, I will go to dimension through navigator, and then I will select OEP FS cube, and from here I will select the members. So for currency, I'm going to fix the USD. For entity, I will be fixing here US, and I will be using @ relative function for US so that its zero level member will be considered. Then for market, I'm selecting no market. Then for plan element, I will select OFS load. For product, I will select brand 1. And scenario, I will be selecting OEP underscore plan. For version, I will select OEP underscore working. And then I will use here and fix. After this, I will go to the accounts. From here, I will select the product. Here we are actually calculating the product revenue. So the member name is OFS underscore product revenue, which will be equal to OFS volume multiplied with OFS average selling price. After that, I will use semicolon. So basically, fixed statement should include member from all dimension other than those within the calculation. If dimension is excluded, or excluded, all members from that dimensions are included. So here we have fixed almost all the dimensions, that is currency, entity, market, plan element, product, scenario, version. Here I need to select, I'm going to use a nested fix function here, and I will fix year total. @ descendants year total. After this, I will save and validate the rule. Nested fix function, where possible, reduces the number of database passes. So here we have used nested fix function. After that we will see the log file, and I will select pass only. So here we see that this rule is taking 0.05 seconds to pass. Okay, now I will go to the smart view sheet. Okay, I'm going to calculate. Like here I'm taking 3000. Now I will run this, I will launch this rule. And I will refresh the smart view sheet. So here we can see that we are getting product revenue for sales, marketing, finance, and operations entity. I want this data to be rolled up to the parent member, that is US. So here I will be using another fix function. Here I will fix product revenue, then volume, then average selling price. I will use here calc dimension, and here I will mention the name of the dimension here, that is entity. Then I will use semicolon. Then after that end fix. Calc dimension, as we all know, helps to aggregate the value, roll up the value to the parent member. So here now I will validate the rule. Then I will deploy it, and then I will launch the rule. Now we can see that the value has been rolled up to the parent member US. Okay, this is the role of calcdim function. Now I'm going to view the log file again. Here we can see that after adding another fixed function, the pass time to run the rule is 5.494 seconds, which is now been which is now more compared to the previous one. So this is what happened in so this is what happened when we write a rule. So to optimize the rule, we need to see how we can make optimum utilization and can reduce the time for writing the rule. That's all for today. Thank you and have a nice day.